Salt analysis. I will teach you my personal and easy trick to learn salt analysis. After watching this lecture completely, you will learn 13 keys of this trick and you will be able to spot cations and anions within second. So watch this lecture till the end and you will learn something awesome. Now what is salt analysis? Well, consider a base sodium hydroxide. When we add water to it, sodium and hydroxide ionize into respective ions. Now this cation of sodium is known as basic radical. It is because this sodium ion belongs to base sodium hydroxide. So we call it basic radical. Secondly, consider an acid like HCl. Now I add some water to it. The acid will ionize into hydrogen ion and chlorine ion. This negative chlorine ion is known as acidic radical. It is because this chlorine ion belongs to acid HCl, so we call it acidic radical. Thirdly, consider a table salt like sodium chloride. We know that this salt is formed from sodium ion and chlorine ion, or we have already learned that sodium ion is known as basic radical and chlorine ion is known as acidic radical. Thus we learn that every salt contains two parts, basic radical and acidic radical, or positive cation and negative cation. Now let I give you an unknown salt and I ask you to identify its cation and anion. What will you do? Well, you will simply identify its basic radical, which is a cation, and you will identify its acidic radical, which is anion. Thus we define salt analysis as the process of identification of the cation and anions of an inorganic salt is called as salt analysis. Let me repeat it. The process of identification of the cations and anions of an inorganic salt is called as salt analysis. Hence note it down all these important points. Now let me teach you my personal trick of salt analysis. Consider this lock. There are 5 keys available to open this lock. I will select first key to open the lock. If it doesn't open the lock, I will select the second key to open the lock. If the second key doesn't open the lock, I will use the third key, the fourth key, and the fifth key. There is 100% possibility that one out of these 5 keys will unlock the lock. Similarly, consider an unknown salt. Here, let me ask you to open the anion part of the unknown salt. Just like the 5 keys of a lock, I will use 5 keys to open or unlock the anion part of any salt. Hence, let me teach you 5 keys to identify anion part of any salt. Consider an unknown salt. We have already learned that we will use 5 keys to unlock its unknown part or anionic part. Firstly, I take some water in 4 different beakers. Secondly, I add the unknown salt to the first beaker, to the second beaker, to the third beaker, and to the fourth beaker. Lastly, I will only keep unknown salt here. Now I will use sulfuric acid H2SO4 in the second, third, and in the fourth key. Remember that in the second and in the third case, we use concentrated sulfuric acid, while in the fourth case, we use dilute sulfuric acid. In the first key, I add barium chloride to unknown salt. If we get white precipitate, then we will add dilute hydrochloric acid to white precipitate. We will get 2 possible options, PPT dissolve or PPT do not dissolve. If PPT dissolve, it is sulfite ion. If PPT do not dissolve, it is sulfate ion. Thus using first key, we can identify sulfite ion and sulfate ion. I mean, we unlock the salt and identify its anionic part. So we will not use the remaining 4 keys. But wait a minute, What if we do not get white precipitate? It means that the first key cannot open the lock. So we will use the second key. And the second key, we add iron sulfide and concentrated sulfuric acid. We will get two possible answers, black precipitate or brown ring. The black precipitate represents nitrite ion and the brown ring represents nitrate ion. Thus using second key, we can identify nitrite ion and nitrate ion. But wait a minute. What if we do not get black precipitate or brown ring? Then we will use the third key. And the third key, we add silver nitrate and concentrated sulfuric acid. We get three possible answers. White color, pale yellow color or yellow color. I write halogen in ascending order. Chlorine, bromine, iodine. The white color indicates chlorine ion. The pale yellow color indicates bromine ion. And the yellow color indicates iodine ion. Thus using the third key, we can unlock chlorine, bromine and iodine ions of any salt. If we do not get white, pale yellow or yellow color, then we will use the fourth key. In the fourth key, we add lead acetate paper and dilute sulfuric acid. We get two possible answers, black precipitate or brisk effervescence. The black precipitate indicates sulfide ion and the brisk effervescence indicates carbonate ion. If we do not get black precipitate and brisk effervescence, then we will use the fifth key. The fifth key is the most simplest key. We only rub the unknown salt. If it smells like a vinegar, it contains acetate ion. Therefore, using first key, we unlock sulfide ion or sulfate ion. Using second key, we unlock nitrite ion or nitrate ion. Using third key, we can unlock chlorine, bromine or iodine ions. Using fourth key, we can unlock sulfide or carbonate ions. And using fifth key, we can unlock acetate ion. Thus note down all these 5 keys to unlock any anion of unknown salt. Now let me teach you 8 keys to unlock cations of any unknown salt. Firstly, let me teach you about original solution. The transparent and aqueous solution of a salt is known as original solution. Its preparation is simple. We take small amount of salt and we add it to cold water or to hot water, or we add a few drops of acid to it in order to dissolve the salt in the water. Hence note down this basic concept of original solution. Now we will use 8 keys in order to unlock cation of any unknown salt. Consider this unknown salt. I will make its original solution in small quantity and I will add it to 8 different beakers. In the first 4 keys, I use solution of ammonium hydroxide. Now in the first key, we add ammonium hydroxide. We get 2 possible answers. Blue color or white color. The blue color indicates the presence of copper ion. The white color indicates the presence of arsenic ion. If I do not get either blue color or white color, then I will use the second key. Now in the second key, I add ammonium hydroxide plus potassium iron cyanide. We get 2 possible answers, bluish white or blue color. The bluish white indicates the presence of zinc ion and the blue color indicates the presence of iron ion. If the first and the second key do not work, I will use the third key. In the third key, I add ammonium hydroxide plus DMG. Remember that DMG stands for dimethyl glyoxime. We get 1 possible answer, red precipitate. This red precipitate indicates the presence of nickel ion. In case if we do not get red precipitate, I will try to use the fourth key. In the fourth key, I add sodium hydroxide plus few drops of blue litmus solution. I get one possible answer as blue layer. This blue layer indicates the presence of aluminium ion. In the fifth key, we add potassium dichromate. We get either yellow precipitate or yellow precipitate. It may be either lead ion or barium ion. Secondly, we add potassium iodide. We get either yellow precipitate or no yellow precipitate. The yellow precipitate indicates the presence of lead ion and the no yellow precipitate indicates the presence of barium ion. In the sixth key, I add ammonium sulfate. As a result, I get white precipitate. The white precipitate indicates the presence of strontium ion. In the seventh key, I add ammonium oxalate. I get white precipitate, which shows the presence of calcium ion. Lastly, in the eighth key, I add Nessler's reagent. I get brown precipitate. It shows the presence of ammonium ion. Hence, using these 8 keys, we can easily indicate the presence of any cation in an unknown salt. Therefore, using these overall 13 keys, we can easily crack any question of salt analysis. I hope that you have learned all about salt analysis.